Imagine standing on the surface of an alien world, the skies painted in colors we've never seen, the landscape shaped by forces that defy the imagination. This is not just a distant dream but a tantalizing glimpse of our future. As we look beyond the confines of Earth, we are embarking on a monumental journey, one that invites us to reimagine what it means to call a place home among the stars. The potential for sustainable habitats in the cosmos ignites our curiosity, urging us to explore the vast possibilities that lie beyond our atmosphere. Every year, we push further into the depths of space, our instruments and intellect revealing realms that were once mere speculations. With advancements in technology and a growing understanding of the universe, we find ourselves on the brink of a new era. The quest for sustainable living beyond Earth is not only about survival, it's a quest for inspiration, creativity, and the very essence of what it means to be human. As we set our sights on the stars, we must consider how to nurture life in environments that are utterly alien to us. The notion of colonizing other planets has captured human imagination for centuries. From ancient myths to modern science fiction, the idea of thriving in the cosmos has been a beacon of aspiration. Yet, this dream is becoming increasingly feasible as we develop the science needed to create habitats where life can flourish away from our blue planet. It's a cosmic challenge that blends innovation with a sense of responsibility, compelling us to consider not just how we can live beyond Earth, but how we can do so sustainably. Our journey takes us through the complexities of astrobiology, the study of life in the universe, where we contemplate not only the environments that could host life as we know it but also those that might support entirely different forms of existence. Understanding life beyond Earth requires us to expand our definitions and expectations, envisioning ecosystems that thrive under conditions we have yet to fully comprehend. It challenges us to think expansively about what sustainability means in environments that may be hostile to human life. Habitat design for space is an intricate tapestry woven from both our knowledge of Earth's ecosystems and our innovative ambitions. Alongside the search for exoplanets, we are grasping the fundamental principles that could allow us to create self-sustaining environments. Imagine a habitat on Mars, where the air is thin and radiation looms, yet life flourishes in carefully designed biospheres, powered by renewable energy sources and utilizing local resources. This vision requires wisdom in design, engineering, and ecology, merging disciplines to craft living spaces that resonate with the rhythms of nature. But as we dream of new worlds, we must also confront the profound ethical implications of our ambitions. The desire to colonize is intertwined with the responsibility to respect and protect whatever life forms we may encounter. It demands that we engage in thoughtful dialogue about our role in the cosmos and how we can ensure that our ventures enrich rather than exploit. Sustainability is not merely a checklist, it is a commitment to coexistence, stewardship, and the well-being of all potential life forms. As we venture further into this cosmic frontier, we face the reality of challenges that lie ahead. The road to establishing sustainable habitats is rife with obstacles, from the technical complexities of building in extreme environments to the psychological demands of living in isolation. Our understanding of community, culture, and well-being will be put to the test as we create societies beyond Earth, navigating the intricacies of human interaction under the pressures of a new environment. Yet, with each challenge comes an opportunity for innovation. The technology we develop to sustain life in space will not only benefit future colonies but will also have implications for how we live on Earth. The lessons learned in creating self-sufficient ecosystems on other planets can inform our efforts to preserve our own environment, fostering a deeper connection to the land we currently inhabit. The possibilities are limitless as we ponder the future of humanity among the stars. We stand at a pivotal moment in history, where the dreams of explorers, scientists, and visionaries intersect. The universe is not just a backdrop for our aspirations, it is an expanse filled with promise, beckoning us to take our place as cosmic architects. Our journey to design sustainable habitats beyond Earth is just beginning, and with it comes the chance to redefine our existence in the grand tapestry of the cosmos. As we set forth on this exploration, let us keep our imaginations alight with wonder and our hearts focused on the values that will guide us. Together, we are not just voyagers crossing the void, we are the creators of a future where life can thrive among the stars, where sustainable habitats become the new homes for humanity, and where our cosmic calling becomes a reality. The adventure has just begun. As we set our sights on the vastness of the cosmos, we are greeted by a staggering reality: our universe is a tapestry woven with billions of stars, each adorned with its own collection of planets, moons, and mysteries waiting to be uncovered. When we look up at the night sky, we catch only a glimpse of this immense expanse. Our Milky Way galaxy alone is home to an estimated 200 billion stars, each a sun that could potentially cradle its own family of worlds. The mere thought of the multitude of planets scattered throughout the cosmos invites us into a realm of infinite possibilities. But let us not stop with our galaxy, for our universe is a grander stage, a colossal arena featuring at least 2 trillion galaxies, each one a universe unto itself. Imagine the sheer scale of what lies beyond our own stellar neighborhood. Each galaxy is a swirling masterpiece of gas, dust, and stars, with vast cosmic voids in between. This incredible scale invites us to ponder our place within it, igniting both curiosity and ambition in equal measure. As we embark on our quest to design sustainable habitats beyond Earth, the cosmic context shapes our understanding of what it means to seek new frontiers. It compels us to look beyond the familiar and to ask profound questions about life itself. Are we alone in this vast universe? What does it mean for a planet to support life? As we expand our gaze, we must also expand our definitions, realizing that life may not always conform to the examples we know. Our search for exoplanets, those tantalizing worlds circling distant stars, offers just a hint of the vast possibilities that await us. In our pursuit, we have discovered planets that exist in the habitable zone of their stars, where temperatures might allow for liquid water, the essential ingredient for life as we know it. But our understanding of habitability goes beyond mere temperature and distance. We must consider the unique conditions of each celestial body, including its atmosphere, magnetic field, and geological activity. The universe presents us with a rich diversity of environments, from rocky worlds to gas giants, each offering a unique laboratory for exploration. Astrobiology, the scientific study of life in the universe, is our guiding star in this endeavor. It asks us to consider life in all its forms and to investigate the potential for life to arise in environments vastly different from our own. This field reminds us that life can be remarkably resilient and adaptable, thriving in conditions that would seem inhospitable to us. Extremophiles here on Earth, microbes that can withstand extreme temperatures, pressures, and radiation, hint at the possibilities that might exist on distant planets. Each discovery serves as a beacon, illuminating our path as we seek out new worlds and the life forms that may inhabit them. Yet, the pursuit of life beyond our home world also raises important questions about how we will inhabit these new environments. The cosmic context compels us to think deeply about our responsibilities as we venture into uncharted territory. What does it mean to create sustainable habitats? How do we ensure that we do not repeat the mistakes of our own planet? This is where the principles of sustainable design come into play, urging us to create living spaces that harmonize with their environments rather than deplete them. Our understanding of sustainability is shaped by the intricate interplay of technology, biology, and ecology. As we consider the possibilities of building habitats on Mars or the Moon, we must design systems that utilize local resources, minimizing the need to transport materials from Earth. Imagine the potential of 3D printing structures using Martian soil, or the use of regolith to create protective barriers against radiation. These innovations align with our cosmic calling, driving us to think creatively and resourcefully as we forge new paths. Energy solutions will play a pivotal role in our extraterrestrial habitats. Harnessing solar energy, abundant throughout the cosmos, offers one of the most promising avenues for powering our endeavors. The vastness of space is rich with sunlight, and developing technologies to capture and store this energy can enable life-sustaining systems in the most remote locations. Coupled with advancements in energy storage, we can envision habitats that thrive using renewable resources, reflecting a commitment to sustainability that resonates across the stars. Water, the essence of life, is another critical element in our cosmic exploration. Understanding where to find water on other worlds, whether in the form of ice on Mars, the subsurface oceans of Europa, or the atmosphere of exoplanets, will be vital to our survival. Techniques for extracting and recycling water will be essential in creating self-sustaining habitats, allowing us to flourish in environments once deemed inhospitable. As we dream of lives beyond Earth, we must also consider the human experience within these new habitats. The psychological aspects of long-term space living cannot be overlooked. Isolation, confinement, and the vastness of space can weigh heavily on the human spirit. Designing communities that foster connection, creativity, and well-being will be just as crucial as the physical structures we create. The cosmic context invites us to imagine a future where humanity thrives among the stars, interconnected through shared experiences, cultures, and values. As we look up at the night sky, we are reminded that we are not just explorers, we are cosmic architects, tasked with a profound responsibility to design a future that is sustainable, compassionate, and awe-inspiring. It is in this grand tapestry of existence that our adventure truly begins. As we embark on this cosmic journey, we turn our gaze toward the vast expanse of the universe, where countless stars twinkle in the darkness. Each point of light represents not just a sun, but potentially a solar system filled with planets, some of which may hold the key to our understanding of life beyond Earth. These extraordinary worlds, known as exoplanets, have ignited our imagination and driven an insatiable curiosity that propels humanity forward into the depths of space. The search for exoplanets began in earnest just a few decades ago, yet it has already transformed our understanding of the cosmos. With advanced telescopes like Kepler and TESS, we have uncovered thousands of these distant worlds, each revealing the rich diversity of planetary systems that exist beyond our own. Some of these planets orbit within the Goldilocks zone, a region around a star where conditions might be just right for liquid water to exist, a fundamental ingredient for life as we know it. Consider the remarkable discovery of Proxima Centauri b, located just over 4 light-years away. It is tantalizingly close, yet shrouded in mysteries yet to be unraveled. This exoplanet orbits within its star's habitable zone and offers a glimpse into the possible conditions that could support life. What secrets does Proxima Centauri b hold beneath its atmosphere? Could it be a barren rock or a lush, green landscape teeming with life? The possibilities are as boundless as our imagination. As our technology improves, we are developing more sophisticated methods to detect and study these far-off planets. By analyzing the light from distant stars, astronomers can glean crucial information about an exoplanet's atmosphere, composition, and temperature. This process, known as transit photometry, allows us to observe how a planet passes in front of its host star, creating a slight dimming effect. These minute changes in starlight can reveal the presence of gases like oxygen, methane, and carbon dioxide, essential clues that could indicate the possibility of life. The implications of discovering potentially habitable exoplanets are profound. Each new world we identify adds to a growing tapestry of possibilities, challenging our understanding of biology and resilience. Life may not flourish only under Earth-like conditions but could adapt to environments we have yet to fully comprehend. Extremophiles on our own planet, organisms that thrive in the harshest conditions, remind us of the resilience of life. If they can endure in the depths of our oceans or the blistering heat of deserts, who's to say what forms life might take in the exotic conditions of far-off worlds? The prospect of life elsewhere in the universe stirs a sense of wonder and ignites our imaginations. With every exoplanet we discover, we step closer to answering the age-old question, are we alone in the cosmos? This quest drives astrobiologists, astronomers, and dreamers alike to investigate the richness of our universe. It is not merely about the numbers or data, it is about the profound implications of what these discoveries mean for humanity's future. As we explore the potential for life on other planets, we must also consider what it means to find it. The very definition of habitability is evolving, expanding beyond Earth-centric perspectives. Conditions that might seem inhospitable by our standards may support forms of life entirely foreign to us. We are learning to broaden our criteria for life, allowing for more imaginative possibilities. Each new discovery pushes the boundaries of our understanding, revealing a universe teeming with potential. The search for exoplanets does not just spark scientific inquiry, it inspires a deeper connection to our own planet and our role within the universe. Each discovery reminds us of the fragility of life and the environments that sustain it. The potential for other worlds to harbor life compels us to reflect on our responsibilities as stewards of Earth. Our actions here have far-reaching consequences, not just for ourselves but for the delicate web of life that extends across the cosmos. As we contemplate the future of humanity in space, the significance of these distant worlds cannot be overstated. They are more than far-off destinations, they are potential havens for future generations, places where dreams of a sustainable existence can become a reality. The allure of new homes in the universe beckons us to innovate, to imagine new ways of living harmoniously with nature, no matter where we may find ourselves. With this understanding, we transition from the thrill of discovery to the tangible task of designing sustainable habitats. The knowledge we gain from these exoplanets will inform our approach to creating environments that nurture life, both on Mars and beyond. The lessons learned from distant worlds can guide us in building habitats that honor the interconnectedness of all living beings, ensuring that our adventures among the stars are thoughtful and deliberate. As we harness the knowledge gained from the search for exoplanets, we stand on the cusp of extraordinary possibilities. The universe is a vast and wondrous place, filled with untapped potential. Our exploration of exoplanets is not merely about seeking life, it is about understanding our place in the cosmos and the legacy we wish to leave behind. With each discovery, we are reminded that our journey has only just begun, and the stars are waiting for us to explore their secrets. As we peer deeper into the cosmos, the question of what life might look like beyond Earth stirs the imagination. We often envision life as we know it, but the universe may hold forms of existence that are entirely alien to us. Each planet and moon presents unique conditions that could give rise to life, shaped by their environments, atmospheres, and histories. Let's journey through our solar system and beyond, exploring the diverse possibilities of life as we don't yet know it. Consider Mars, our closest planetary neighbor, with its cold, arid landscape and thin atmosphere. While we think of life as thriving in water, ancient Mars may have once been a vibrant world, teeming with microbial organisms that adapted to its changing climate. Today, if life exists, it could be lurking deep below the surface, where warmth and minerals are more abundant. Imagine tiny, resilient bacteria, perhaps similar to extremophiles on Earth, thriving in the dark, saline waters of underground aquifers, clinging to life in a harsh world. Then there's Europa, one of Jupiter's icy moons, shrouded beneath a thick shell of ice. Beneath this frozen exterior lies a vast ocean, and scientists speculate that hydrothermal vents on the ocean floor could create a nurturing environment for life. Picture bioluminescent organisms, glowing gently in the dark waters, forming complex ecosystems sustained by chemical reactions instead of sunlight. Such life forms might resemble Earth's deep-sea creatures, but their biology could be radically different, adapted to thrive in frigid temperatures and complete darkness. Moving further outward, we encounter Titan, Saturn's largest moon, enveloped in a thick atmosphere and boasting rivers and lakes of liquid methane and ethane. Here, life might not rely on water at all. Instead, imagine organisms that harness energy through completely different biochemical pathways, perhaps utilizing methane as a solvent. These hypothetical beings could be entirely unrecognizable to us, potentially resembling the bizarre extremophiles found in Earth's own methane-rich environments. Beyond our solar system lies an incredible array of exoplanets, worlds that may host life in forms we can hardly fathom. Some planets orbit their stars at such extreme distances that they are frozen wastelands, while others are scorching hot, bathed in intense radiation. Yet, life has a remarkable tendency to find a way. On a super-Earth, with higher gravity and a thicker atmosphere, life could evolve to be much larger and more robust than terrestrial life, adapting to pressures and conditions we can only dream of. Further still, there are ocean worlds, like those orbiting the stars of the TRAPPIST-1 system, where planets are situated within the habitable zone, a region where conditions might allow for liquid water. These planets could host diverse ecosystems derived from the chemistry of their environments, leading to the possibility of sentient beings contemplating their own existence in a very different way than we do. Even in the harsh conditions of gas giants, where temperatures soar and pressure mounts, floating life forms could exist in the upper atmospheres. Vast colonies of organisms, perhaps akin to jellyfish, might drift along the winds, harvesting energy from the planet's immense storms. These life forms could have adapted to survive in an environment where solid ground is a distant concept, showcasing the incredible versatility of life. The potential for life as we don't know it raises profound questions about the nature of existence itself. If life can thrive in such diverse and extreme environments, what does that mean for our understanding of biology? It challenges the assumptions we've made based on our own Earth-centric view and invites us to consider that life may be a fundamental part of the universe, taking forms we have yet to imagine. Astrobiologists are now grappling with these ideas, developing new frameworks for defining habitability. Rather than simply looking for Earth-like conditions, we are expanding our search criteria to include a wider array of environmental factors. This exploration is not limited to familiar compounds like carbon and water. It encourages us to think about alternative biochemistries and how life might adapt to thrive under conditions that would otherwise seem inhospitable. In this cosmic context, the search for life takes on an exhilarating complexity. Each exoplanet we discover, each moon we analyze, adds a piece to this vast puzzle. The implications of finding life, especially forms that diverge significantly from our own, could transform our understanding of biology, evolution, and the potential for intelligent life elsewhere in the universe. As we prepare to venture into this new frontier of cosmic exploration, our imaginations stretch beyond the confines of Earth. The prospect of encountering life that is both familiar and utterly foreign ignites a sense of wonder and possibility. It nudges us to redefine our own existence and our responsibility as custodians of our planet, echoing the profound truth that we are part of a much larger tapestry woven across the cosmos. The diversity of possible life forms inspires not just scientists but also dreamers, visionaries, and storytellers. It reminds us that the universe is not static, it is alive with potential, waiting for us to reach out and discover. With each step into the unknown, we inch closer to answering age-old questions about our origins and our place in the grand narrative of existence. As we continue to look to the stars, the quest for understanding life beyond Earth remains one of humanity's most compelling journeys, full of mystery and promise. To unravel the enigma of life beyond our own planet, we must first contemplate what truly makes a world habitable. Not all celestial bodies possess the qualities required to support life as we know it, and defining habitability involves examining a blend of essential factors. These criteria paint a vivid picture of the conditions necessary for life to flourish, whether it be microbial organisms or complex multicellular beings. At the heart of habitability lies the atmosphere, acting as a shield against the harshness of space. A planet's atmosphere plays a pivotal role in regulating temperature, protecting life from harmful radiation, and facilitating essential chemical processes. Earth's atmosphere, rich in nitrogen and oxygen, is a fine-tuned blend that not only sustains our existence but also nurtures a delicate balance that supports diverse ecosystems. When we gaze outward, we seek worlds with atmospheres that can offer similar protective qualities. Too thin, and they expose surfaces to cosmic rays; too thick, and they may create unbearable pressure or temperature extremes. The right atmospheric composition could be the key to unlocking a world's potential for life. Temperature, the second cornerstone of habitability, directly influences the chemistry of life. Every organism on Earth thrives within specific temperature ranges, where biochemical reactions occur at optimal rates. The concept of the Goldilocks zone emerges here, that perfect sweet spot around a star where conditions are neither too hot nor too cold. This zone allows for the possibility of liquid water, a vital ingredient for life as we know it. Beyond these regions, extreme temperatures can either freeze potential life forms in ice or vaporize them in boiling seas. Water, in its liquid form, is often dubbed the essence of life. On Earth, it serves as a solvent, a transport medium, and a participant in countless biochemical reactions. The search for extraterrestrial life often leads us to look for signs of water, whether in the form of vast oceans, subterranean lakes, or even vapor in the atmosphere. Mars, with its ancient riverbeds, and the icy moons of Jupiter and Saturn, such as Europa and Enceladus, present tantalizing clues that water may once have flowed, or may still flow, beneath their surfaces. These bodies tantalize us with the prospect of life, hinting at ecosystems that could have thrived long ago or that might exist in hidden pockets today. But habitability extends beyond the mere presence of these elements. It involves an intricate interplay of geological and climatic factors that shape a planet's surface and its ability to support life. The presence of a magnetic field can protect an atmosphere from being stripped away by solar winds, as seen on Mars, a once wet planet that lost its protective shield and, with it, much of its atmosphere. Additionally, the planet's geology can contribute to a dynamic environment where nutrients cycle and ecosystems develop. Volcanoes can enrich the soil, while tectonic activity can create varied habitats, each with its own microclimates. As we explore the cosmos, we also confront the possibility of life forms that don't rely on the same conditions that we do. Astrobiology encourages us to broaden our definitions of habitability and consider environments that, at first glance, may seem inhospitable. For example, the extreme conditions found in Earth's deep-sea vents, where life thrives in complete darkness and near boiling temperatures, challenge our understanding of the requirements for life. If life could emerge in such unlikely settings, could we find beings adapted to conditions on planets where temperatures soar, or where the atmosphere is dominated by methane or ammonia? In this cosmic quest, scientists are developing a more nuanced understanding of what it means for a planet to be habitable. As we analyze exoplanets through advanced telescopes, we look for signs of atmospheres that might harbor the right elements for life, searching for indicators of water, carbon dioxide, and other compounds that suggest a potential for life-sustaining processes. Each discovery expands our knowledge, revealing the intricate tapestry of possibilities that exist in the universe. Yet, defining habitability also has implications for our own aspirations of colonization. As we dream of establishing habitats on planets like Mars or moons like Europa, we must consider not just the conditions necessary to survive, but also to thrive. This means developing technologies that can replicate Earth-like environments, providing the atmosphere, temperature controls, and water recycling systems required for long-term human presence. In this grand design, understanding habitability is just the beginning. The exploration of other worlds challenges us to reimagine not only what is possible beyond Earth but also what our own planet's future might hold. Each discovery not only answers questions but also sparks new inquiries, leading us towards a greater comprehension of life's resilience and adaptability across the universe. The journey to define habitability is an ongoing adventure, one that invites us to ponder the limits of life, the vastness of potential, and the profound connections we share with the cosmos. Astrobiology stands at the intersection of biology, chemistry, and planetary science, a vital field that seeks to unravel the mysteries of life throughout the universe. As we send our probes into the depths of space, astrobiology serves as a guiding star, illuminating our path as we seek to understand not just where life might exist, but how it thrives in environments vastly different from our own. This discipline compels us to expand our understanding of the conditions necessary for life and challenges us to look beyond Earth's familiar landscapes. The significance of astrobiology grows as we delve deeper into the cosmos. It encourages us to consider the diverse forms life could take, nurturing our imagination while firmly rooting our explorations in scientific inquiry. By examining extreme environments on Earth like the scorching deserts, deep-sea hydrothermal vents, and frozen tundras, we gain insights into the tenacity of life. These resilient organisms, known as extremophiles, showcase nature's ingenuity, revealing how life can adapt to conditions we once thought inhospitable. This knowledge boosts our confidence as we scout other worlds, from the frozen plains of Europa to the sulfuric clouds of Venus, and seek to find out whether life could flourish in those alien realms. One of the most profound contributions of astrobiology lies in its ability to shape our search for exoplanets. With telescopes that peer hundreds of light-years into the night sky, scientists are identifying planets located in the Goldilocks zone, where conditions might be just right for liquid water to exist. Astrobiology empowers this quest by helping us to define the key characteristics of these distant worlds. We learn to analyze their atmospheres, surface conditions, and orbital dynamics, all through the lens of what we know about life's requirements. Each exoplanet discovery not only fuels our curiosity but also enriches our understanding of what habitability truly means in a cosmic context. As we ponder the possibility of life elsewhere, astrobiology urges us to rethink our notions of what constitutes a suitable habitat. We may envision life as we know it, but the universe could hold extraordinary surprises. Imagine silicon-based organisms capable of thriving in the scorching heat of a star's corona or microbial life existing in the depths of an ocean beneath an icy crust. The key to unlocking these secrets lies in our willingness to embrace the unknown and expand our parameters of what life can be. This twist of perspective challenges us to explore environments we might otherwise dismiss, recognizing that life's adaptability could be more profound than we've ever imagined. In guiding our search for extraterrestrial habitats, astrobiology also informs our understanding of how to create sustainable living environments for humans beyond Earth. By studying habitats that have already been successful in fostering life on our planet, we can extrapolate lessons that apply to Mars, the Moon, and even artificial environments constructed in space. Each insight into microbial life and ecological balance enhances our ability to design systems that support human existence in alien environments. By implementing principles derived from astrobiology, we can create closed-loop ecosystems that recycle air, water, and nutrients, reducing our reliance on resupply missions from Earth. Astrobiological research also promotes interdisciplinary collaboration, drawing together experts from diverse fields to tackle the complexities of life in the universe. Biologists, chemists, physicists, and engineers combine their knowledge to explore questions that transcend traditional boundaries. This synthesis of disciplines is essential as we embark on ambitious ventures, like establishing colonies on Mars or creating biospheres on the Moon. Each step forward is a testament to human ingenuity, further fueled by the foundational insights of astrobiology. Moreover, astrobiology plays a crucial role in shaping our understanding of potential biosignatures, signs of life we might encounter on other worlds. Researchers are developing techniques to detect chemical signatures in the atmospheres of exoplanets that could suggest biological processes at work. From the presence of methane to oxygen in unusual concentrations, these indicators could point to life forms that have adapted to their unique surroundings. By honing our ability to recognize these signals, we become better equipped to discern the subtle nuances that differentiate a lifeless world from one teeming with vitality. As we prepare for future explorations, the ethical implications of astrobiology cannot be overlooked. Understanding the potential for life elsewhere raises profound questions about the responsibility we have toward those ecosystems. If we find life beyond our planet, what rights will those organisms hold? How do we balance exploration with preservation? These inquiries push us to consider the broader implications of our cosmic calling, reminding us that our actions on distant worlds must reflect our values as a species. Ultimately, the role of astrobiology transcends the mere search for extraterrestrial life. It invites us to reflect on our place in the universe and the interconnectedness of all life forms, urging us to consider the future of humanity in a broader cosmic narrative. As we strive to build sustainable habitats beyond Earth, the lessons of astrobiology remind us that adaptability, resilience, and curiosity are fundamental traits not just of life on Earth, but of life itself, wherever it may be found. With every discovery in astrobiology, we draw closer to understanding the rich tapestry of life that could exist among the stars. These insights fuel our aspirations and imbue our quest for colonization with purpose. They inspire a vision of a future where humanity thrives alongside other life forms, united by our shared journey across the cosmos, exploring new frontiers, and crafting a sustainable existence in the vastness of space. As we step into this new chapter of cosmic exploration, the principles of sustainability become our guiding stars, illuminating the path toward designing habitats that can support human life beyond Earth. In the harsh and unforgiving environments of other worlds, the rules of architecture and engineering must adapt to the unique challenges presented by these alien landscapes. To survive and thrive, we must embrace a holistic approach that prioritizes efficiency, resilience, and harmony with the surrounding environment. At the heart of sustainable habitat design is the concept of closed-loop systems. In the vastness of space, resources are finite, and waste can become a formidable adversary. Imagine a habitat where air and water are continuously recycled, where every drop of moisture is captured and repurposed, and where the very breath we exhale is converted back into life-sustaining oxygen. This interconnectedness mimics the delicate balance found in Earth's ecosystems, ensuring that nothing is wasted, and everything has a purpose. Such systems not only sustain human life but also create a sense of unity with the cosmos, reminding us that we, too, are part of a larger ecological web. Energy efficiency is another pivotal aspect of sustainable design. Beyond our home planet, traditional energy sources are impractical. Instead, we must harness the abundant energy of the sun, even from millions of miles away. Solar panels, designed to capture and convert sunlight into usable power, can adorn the surfaces of habitats, converting the harsh rays of distant stars into lifeblood for our colonies. This technology can be complemented by innovative storage solutions, allowing us to store energy for when the sun isn't shining. The result is a self-sufficient habitat that relies on renewable energy, minimizing our dependence on Earth and ensuring that our presence in space is sustainable. Biophilic design principles, an approach that connects inhabitants with nature, can also play a vital role in creating sustainable habitats. While other planets may not host the familiar greenery of Earth, we can cultivate a sense of nature through artificial environments. Living walls, vibrant gardens and biodomes, and even simulated sunlight can provide psychological and emotional benefits, reminding us of home. By incorporating elements of nature into our designs, we foster well-being, reduce stress, and enhance the quality of life in our off-world communities. Sustainable habitat design must also prioritize material efficiency. In space, transporting materials is a costly endeavor, and every kilogram counts. We will need to utilize local resources, or in situ resource utilization, to minimize reliance on Earth. This means harnessing the very soil and rocks of celestial bodies like Mars or the Moon to create building materials. Imagine robots extracting regolith, the loose material covering planetary surfaces, and transforming it into concrete-like structures that can form the backbone of our habitats. This approach not only conserves resources but also establishes a profound connection between the habitat and its new home, embedding our existence into the fabric of the universe. Water, as we've discussed, is the essence of life, and its management is critical in sustainable habitat design. Innovative systems might capture and recycle every drop, but we must also explore ways to source water from the environments we inhabit. For example, ice deposits found beneath the surface of the Moon or the polar caps of Mars could provide essential resources for our colonies. Developing technologies that can extract and purify this water will be vital to ensuring we can sustain ourselves in these distant worlds. The psychological aspects of living in these habitats cannot be overlooked. Prolonged isolation in confined spaces can take a toll on mental health. To counter this, habitats must not only be efficient but also promote community and connection. Design features that encourage social interaction, communal spaces, and personal privacy can help foster a sense of belonging among inhabitants. Cultivating a strong sense of community will be as essential as the physical structures we build. As we envision these sustainable habitats, we must also grapple with the ethical implications of our presence on other worlds. The idea of space colonization evokes a myriad of questions about our responsibilities as cosmic explorers. How do we ensure that our designs respect and preserve the untouched beauty of extraterrestrial landscapes? Developing habitats that have a minimal ecological footprint is crucial. This means conducting assessments to understand the impact of our presence and emphasizing designs that blend seamlessly into the environment, minimizing disruption to the planetary ecosystems we encounter. Sustainability is not merely a goal, it is a philosophy that must inform every decision we make as we reach for the stars. From the drawing board to the construction site, our designs must reflect a commitment to living in harmony with the cosmos, prioritizing the well-being of both ourselves and the worlds we inhabit. By embracing these principles, we lay the groundwork for a future where humanity does not just survive but flourishes in the cosmos, creating vibrant, sustainable communities that resonate with the infinite potential of the universe. As we continue to explore the possibilities of living among the stars, we are reminded that our greatest challenge is not merely building homes but cultivating a deeper connection with the universe itself. Through sustainable design, we aim to honor the legacy of life on Earth as we venture forth, crafting habitats that nurture both humanity and the celestial environments we inhabit. This journey towards sustainability is our profound calling, and it beckons us to imagine a future where we are not just visitors, but stewards of our cosmic home. As we gaze toward the horizon of our solar system, Mars emerges as a tantalizing candidate for human colonization. Often dubbed the Red Planet, Mars captivates our imagination with its rugged terrain, polar ice caps, and the haunting remnants of ancient riverbeds. Yet, what draws us to this distant world isn't just its surface, it's the tantalizing possibility that it could become our next home. But to transform this barren landscape into a thriving habitat, we must confront an array of challenges that test our ingenuity and resolve. Mars presents a harsh environment that would be daunting for even the most resilient of species. The thin atmosphere, composed mostly of carbon dioxide, offers little protection from cosmic radiation and the extreme temperatures that can plunge to -195 degrees Fahrenheit at the poles. Dust storms, some larger than entire continents, can envelop the planet for months, creating additional obstacles. Yet, each of these challenges also spurs innovative thinking, urging us to devise solutions that push the boundaries of technology and sustainability. To conquer the thin Martian atmosphere, we must design habitats capable of shielding humans from radiation while also recapturing and reusing resources. Advanced materials, such as aerogels and radiation shielding composites, could play a critical role in constructing these protective environments. Beyond mere survival, these habitats will need to foster a sense of community, well-being, and purpose that mirrors the vibrancy of life on Earth. Water, our most precious resource, lies at the heart of any sustainable endeavor on Mars. Hidden beneath the Martian surface and locked within polar ice caps, water is both a challenge and an opportunity. Cutting-edge technologies such as ice mining and atmospheric extraction could provide the necessary water supply for drinking, agriculture, and sustaining life. By leveraging these resources, we can establish a closed-loop system that recycles water, ensuring that every drop is cherished and utilized efficiently. Food production on Mars poses its own set of unique challenges. With limited sunlight and a harsh environment, traditional farming methods are impractical. However, innovative approaches such as hydroponics and aeroponics could revolutionize how we cultivate food in space. By growing crops in nutrient-rich water or mist, we can create thriving agricultural systems that require minimal space and resources. Additionally, genetic engineering may allow us to create plant varieties that are more resilient to Martian conditions, opening the door to sustainable food sources that could sustain a growing population. Beyond the technological hurdles, we must consider the psychological aspects of living on Mars. The isolation, confinement, and distance from Earth could weigh heavily on the minds of colonists, making it essential to design habitats that promote mental health and social interaction. Environments that mimic Earth's natural landscapes could help ease feelings of homesickness. Shared spaces for recreation, art, and community gatherings will become vital to maintaining a sense of belonging, fostering a vibrant culture that thrives even in the vastness of space. Integral to the success of Mars colonization will be our approach to community and governance. Developing a society on Mars involves not only logistics but also the ethical implications of colonization. As we establish our presence, we must navigate the delicate balance between exploration and exploitation, ensuring that we act as responsible stewards rather than conquerors. This means considering the impact of our actions not only on the Martian environment but also on future generations of humans who may one day call this planet home. Yet, the journey to colonizing Mars is laden with challenges, from the physical to the philosophical. Each step forward reveals new obstacles, but it is through these trials that we discover our capacity for innovation and resilience. The spirit of exploration has always been a driving force behind humanity's greatest achievements, and as we set our sights on Mars, we tap into this wellspring of creativity and determination. The potential for human settlement on Mars serves as a microcosm for our aspirations beyond Earth. It invites us to rethink our relationship with the cosmos and each other. As we plan for our future on this alien world, we must also reflect on the lessons learned from our stewardship of Earth. The design principles we apply on Mars should echo the sustainable practices that protect our home planet. In doing so, we honor our roots while simultaneously reaching for the stars. Mars, then, is not merely a destination but a proving ground for our capabilities as cosmic architects. It is a canvas upon which we can paint a future filled with hope and possibility. By embracing our role as stewards of both Earth and Mars, we pave the way for a new chapter in human history, a narrative of resilience, collaboration, and harmony with the universe. As we inch closer to the day when we might set foot on Martian soil, we find ourselves at the precipice of a remarkable transformation. Each technological advance, each scientific breakthrough, brings us closer to realizing the dream of a sustainable human presence on another planet. In our quest to make Mars the next home, we are not just charting a course through space, we are redefining what it means to be a part of this vast and mysterious cosmos. The journey ahead is fraught with challenges, but it is also rich with the promise of discovery, innovation, and the boundless potential of a united humanity reaching for the stars. As we contemplate the future of human life beyond Earth, our gaze naturally drifts to our closest celestial neighbor, the Moon. Once merely a distant beacon in our night sky, the Moon now stands as a pivotal platform for our expansion into the cosmos. Its rugged surface, dotted with craters and ancient plains, offers not just a location for exploration but a canvas upon which we can paint our future in space. In this new chapter of human exploration, building on the Moon could serve as a springboard for deeper ventures into the solar system and beyond. Lunar habitats, unlike any we have known, would need to be carefully designed to withstand the harsh conditions of the Moon. With its thin atmosphere and extreme temperature variations, the Moon presents unique challenges. Daytime temperatures can soar to over 100 degrees Celsius while nighttime plunges into the depths of minus 150 degrees. To thrive in such an environment, habitats must be insulated against these swings and shielded from cosmic radiation, which poses a significant risk to human health. Imagine domes of transparent aluminum, shimmering under the distant sun, housing our future lunar settlers. These structures could be constructed using lunar regolith, the fine dust and rocky debris that blankets the surface. By utilizing in situ resources, we can minimize the need to transport materials from Earth, making the endeavor more sustainable and feasible. This concept, known as resource utilization, allows us to rethink our relationship with the Moon, transforming a lifeless rock into a nurturing environment for humanity. The Moon's low gravity, roughly 1/6 that of Earth's, presents both an advantage and a challenge. While it may ease the logistics of construction and allow for unique engineering solutions, it also complicates our physical adaptation. Designing habitats with this factor in mind will be crucial in supporting human health and functionality over long periods. In the absence of Earth's gravitational pull, our physiology could change in ways we have yet to fully understand. But lunar habitats are not just about survival, they will be spaces for thriving. We envision vibrant communities where people can live, work, and play. With the right designs, these habitats could feature greenhouses that utilize hydroponics to grow food, recreational areas that mimic Earth's environments, and laboratories to conduct groundbreaking scientific research. This blend of functionality and livability is essential for the psychological well-being of inhabitants. Just as human beings crave connection and community on Earth, so too will they in the stark solitude of the Moon. The Moon's strategic position also makes it an ideal launching pad for missions to Mars and beyond. By establishing a permanent presence on the lunar surface, we can develop and test technologies for long-duration space travel. Rockets could be launched from the Moon with far less fuel than those from Earth, taking advantage of the Moon's lower gravitational pull. This could revolutionize the logistics of interplanetary exploration, making previously unimaginable journeys feasible. As we build on the Moon, we are not just constructing habitats, we are laying the groundwork for a new era of human exploration. The lunar surface could become a hub for research, innovation, and collaboration among nations. Imagine international teams working side by side, sharing knowledge and resources to unlock the mysteries of the universe. The Moon might become a beacon of global unity, a testament to what we can achieve together when we look beyond our terrestrial divisions. Yet, this vision comes with responsibilities. As we embark on this new frontier, we must consider the ethical implications of our actions. The Moon is not a blank slate, it is rich with history and significance. The footprints of Apollo astronauts still mark its surface, reminders of humanity's first steps beyond Earth. We must tread carefully, ensuring that our efforts do not desecrate this celestial body. Preserving the Moon's heritage while nurturing our future is a delicate balance that will require thoughtful stewardship. Additionally, the lunar environment presents unique challenges for sustaining human life. The Moon's lack of liquid water poses a significant hurdle. However, recent discoveries of water ice in permanently shadowed craters raise exciting possibilities. If we can harness this resource, it could be used for drinking water, oxygen production, and even fuel for rockets. The ability to extract and utilize these precious resources would be a game-changer, turning the Moon into a self-sufficient outpost for humanity. The potential of building on the Moon extends beyond immediate survival. It is a step toward understanding how to create sustainable habitats for life in the harshest environments. The lessons we learn from lunar colonization will inform our efforts on Mars and potentially on exoplanets in the distant future. Each successful mission, each thriving habitat, adds to our knowledge bank, paving the way for future generations to explore the cosmos. In this era of cosmic architects, the Moon is not just a destination, it is a launchpad for dreams. It invites us to envision a future where humanity is no longer confined to a single planet, but can traverse the stars, exploring the wonders of the universe. With every ounce of ingenuity and ambition, we are crafting a story of resilience, innovation, and exploration that spans not just decades, but centuries. As we look up to the Moon, we are reminded that our aspirations are infinite, echoing through the vastness of space and time, waiting for us to reach out and embrace them. The challenges of living beyond Earth, however, extend far beyond the physical journey to another world. Once we arrive, we must create environments that can foster human life, shielding us from the unyielding harshness of space. Here, artificial biospheres emerge as a vital solution, intricate ecosystems designed to support life, even in the void. These engineered habitats are not merely protective shells, they are self-contained worlds, meticulously crafted to replicate the delicate balance of Earth's ecosystems. Imagine stepping inside a vast dome, where everything is engineered to perfection. The air is rich with oxygen, the temperature is meticulously controlled, and the nutrient cycle mirrors that of Earth. Within this dome, each element is interdependent, from the smallest microbe to the tallest plant. This synergy is not just a design preference, it is a necessity. If we are to thrive in space, we must mimic nature's incredible ability to sustain life through interconnected systems. The creation of these artificial biospheres hinges on our understanding of ecology and biology, pushing the boundaries of science and technology. As we explore the concept of biospheres, we delve into the heart of astrobiology, which examines the potential for life in environments vastly different from our own. Researchers are studying extremophiles, organisms that thrive in some of the harshest conditions on Earth, to inspire designs for these extraterrestrial havens. These microscopic pioneers teach us valuable lessons about resilience, adaptability, and the fundamental requirements for life. By harnessing these principles, we can design habitats that not only protect but also nurture human life, creating a space where we can grow and flourish. The International Space Station has served as a proving ground for these ideas. It functions as a microcosm of Earth, providing a glimpse into the future of long-duration space living. Experiments conducted in its controlled environment have yielded insights into how plants grow in microgravity, how we recycle air and water, and how human psychology adapts to isolated conditions. Each experiment brings us closer to understanding the intricacies of maintaining life beyond our planet, laying the groundwork for more advanced biospheres. Biospheres in space are not merely about survival, they are about creating a sense of home. Imagine a habitat filled with greenery, the gentle hum of life all around, where sunlight filters through transparent domes, and crops sway in the air. These environments must be designed to enhance our physical and psychological well-being. The introduction of natural elements, plants, water features, and even the sounds of birds can reduce stress and promote a sense of belonging. In a world detached from Earth, these biospheres could become sanctuaries, offering comfort and familiarity amid the unknown. Energy is another vital component of these artificial environments. Solar power, a bountiful resource in space, offers a sustainable solution for energy needs. Advanced solar panels could harness sunlight, converting it into electricity to support life-sustaining systems. This energy would power hydroponics farms, provide lighting, and maintain the climate controls essential for keeping the biosphere stable. Moreover, innovations in energy storage, such as advanced batteries or even nuclear power, could ensure a continuous supply of energy, regardless of the position of celestial bodies. Water, the essence of life, presents both a challenge and a crucial element in the construction of space habitats. Recycling systems that mimic the natural water cycle will be essential, capturing moisture from the air and purifying it through advanced filtration technologies. The presence of water allows for not only hydration but also food production through aquaponics, where fish and plants can coexist in a mutually beneficial environment. Each drop of water becomes a precious resource, a reminder of the fragility of life in the cosmos. The psychological aspects of living in these artificial environments cannot be overlooked. As humans, we thrive in social settings, and isolation can lead to a range of psychological challenges. Designing these biospheres must take into account communal spaces that foster interaction, creativity, and companionship. Spaces for recreation, shared meals, and collaborative projects will be crucial in maintaining mental health and a sense of community. As we venture further into space, the importance of human connection will remain at the forefront of our design principles. Food production in space also plays a vital role in the success of these biospheres. Innovations in agricultural technology are paving the way for sustainable food sources that can thrive in confined environments. Vertical farming, for example, allows for the cultivation of crops in stacked layers, maximizing space while providing fresh produce. These systems can be integrated into the biosphere, ensuring that inhabitants have access to nutritious food, thereby reducing dependency on resupply missions from Earth. As we consider the complexities of building artificial environments, the ethical implications of space colonization must be front of mind. The responsibility that comes with creating new habitats extends beyond mere survival. We must approach this endeavor with a sense of stewardship, ensuring that we do not replicate the mistakes of our past on Earth. The question of how we coexist with potential extraterrestrial life and how we respect the environments we inhabit becomes paramount. In essence, the creation of artificial biospheres represents a profound synthesis of science, technology, and human spirit. These intricate ecosystems will be our new homes, a testament to our ability to adapt and innovate. As we stand on the brink of interplanetary living, the wonders of these artificial environments remind us of our place in the cosmos, igniting our imagination and inspiring us to dream beyond the stars. The journey toward creating sustainable habitats for life beyond Earth is not just a scientific endeavor, it is a reflection of our deepest aspirations and our enduring quest to explore the unknown. As we stand at the precipice of interplanetary exploration, the concept of terraforming emerges as one of the most audacious ideas of our time. Imagine transforming a barren landscape into a thriving world, one where human life can flourish under alien skies. This ultimate transformation envisions a future where planets like Mars or Venus become new homes for humanity, reshaping their atmospheres, climates, and ecosystems to mimic the nurturing conditions of Earth. Terraforming is not merely science fiction, it is a tantalizing possibility that beckons us to rethink our role in the universe. At its core, this process involves altering a planet's environment to make it more Earth-like. For Mars, this might mean thickening its thin atmosphere to trap heat, creating a warmer climate that can support liquid water. The potential methods for achieving this are as varied as they are fascinating, ranging from releasing greenhouse gases to deploying giant mirrors in space to reflect sunlight and warm the surface. Each idea presents its own challenges and implications, calling upon our ingenuity and ethical considerations. Let's take a closer look at Mars, often touted as the best candidate for terraforming. The red planet, with its polar ice caps, ancient riverbeds, and signs of past water, hints at a more hospitable history. The idea of transforming Mars into a lush landscape filled with lakes and greenery ignites our imagination. But how would we start? Enormous engineering projects could be initiated, such as bombarding the poles with asteroids or comets rich in water and carbon dioxide. These impacts could release gases into the atmosphere, thickening it and gradually raising temperatures. However, the path to a terraformed Mars is fraught with complexities. The planet's gravity is much weaker than Earth's, which raises questions about the long-term retention of an atmosphere. Would it naturally dissipate over time, leaving humanity to perpetually intervene? These challenges not only require advanced technologies but also a deep understanding of planetary sciences and environmental systems. It's a delicate dance between science and nature, reminding us that life is not only the product of chemistry but also of coevolution with its environment. While Mars inspires visions of terraforming, Venus presents an even more complex challenge. With its crushing pressure and toxic atmosphere, transforming the second planet from the Sun seems daunting, yet not impossible. Some scientists propose cooling its surface by reflecting sunlight or even introducing photosynthetic organisms that can survive in extreme conditions to begin the slow process of altering the atmosphere. The science of terraforming involves ambitious thinking, pushing the boundaries of what we believe is feasible and igniting discussions about humanity's place in the cosmos. The implications of terraforming extend far beyond the technical challenges. They compel us to consider the ethical dimensions of such transformations. Should we reshape other planets to suit our needs, or do we have a responsibility to preserve their natural states? These questions stir profound debates within the scientific community and society at large, touching on themes of colonialism, environmental stewardship, and the rights of hypothetical extraterrestrial ecosystems. As we explore the cosmos, we must grapple with the ethics of our actions and the long-term consequences of our expansion. As we ponder our cosmic journey, we should also consider the role of technology in making terraforming a reality. Innovative approaches in genetics, artificial intelligence, and environmental engineering will be crucial in this endeavor. For instance, genetically modified organisms could be designed to thrive in alien conditions, gradually transforming the atmosphere through photosynthesis or other processes. Such advancements not only reflect our progress in biotechnology but also demonstrate our ability to design life itself. Energy solutions will also play a pivotal role in terraforming. Harnessing the power of the sun through solar panels or exploring nuclear options could provide the necessary energy to power the vast machinery needed for these transformations. We have yet to tap into the full potential of fusion energy, a clean and virtually limitless source of power that could one day drive the terraforming processes across our solar system. As we invest in these technologies, we not only prepare for the challenges ahead but also create a legacy of innovation and exploration. Water, the essence of life, is a crucial factor in any terraforming strategy. For Mars, finding and utilizing water sources effectively could lay the foundation for sustaining human life. Subsurface ice deposits or potential briny liquid water may provide the key to establishing habitats and agriculture in a terraformed environment. The journey to create a viable ecosystem involves understanding the intricacies of water cycles, soil composition, and climate dynamics, akin to those we respect on Earth. The psychological aspects of living in transformed environments also warrant careful consideration. How would humans adapt to life on a new world? What social structures might emerge in these alien landscapes? Communities could form around shared endeavors, fostering a culture that bridges Earth and its new colonies. To thrive in such an environment, we would need to cultivate resilience and adaptability, learning from the challenges that come with this unprecedented leap into the unknown. As we imagine the possibilities of terraforming, we find ourselves at a pivotal moment in our evolution as a species. The journey toward creating a sustainable presence among the stars challenges us to rethink our responsibilities, our innovations, and our vision for the future. This cosmic calling pushes us to not only look outward but also to reflect on our connection to our home planet, ensuring that our quest to terraform other worlds is conducted with the wisdom and reverence that all life deserves. The potential for creating new homes in the cosmos is exhilarating, and as we boldly venture into this frontier, we hold the dreams of generations past and future within our hands. Advancements in technology are at the very heart of our journey to create sustainable habitats beyond Earth. As we stand on the brink of this new frontier, innovations like 3D printing and robotics are transforming our aspirations into tangible realities. Imagine an astronaut on the surface of Mars, surrounded by a landscape that is both alien and inviting, armed with technology that allows them to construct a living space from the very materials they find around them. This is not just a dream, it's a glimpse into our potential future. At the forefront of this revolution is 3D printing, a technology that has already changed the way we think about manufacturing on Earth. In the context of space habitats, it opens doors to creating structures that are not only efficient but also customizable and adaptable. By using materials found on other planets, such as regolith on the Moon or Mars, 3D printing can build habitats that minimize the need to transport heavy construction materials from Earth. This process not only reduces costs and logistical challenges but also embraces the idea of using local resources, an essential principle for sustainability in space. Imagine a 3D printer capable of transforming Martian soil into sturdy bricks or walls, layering them with precision to form habitats that can withstand harsh conditions. This technology can create everything from simple shelters to complex structures equipped with life support systems, all designed to foster human life in environments that are inhospitable by earthly standards. By iteratively printing and refining designs, we can ensure that these habitats are not just functional but also conducive to the well-being of their inhabitants. Robotics, too, plays a pivotal role in this transformation. Autonomous drones and rovers equipped with advanced sensors can scout the landscape, identify suitable building sites, and even assist in the construction of habitats. They would work tirelessly, overcoming challenges like dust storms or extreme temperatures, while humans focus on more complex tasks. The synergy between human ingenuity and robotic efficiency could revolutionize the way we establish our presence on other worlds. Both technologies enable a shift in our approach to habitat design. Instead of viewing these projects as monumental undertakings fraught with uncertainty, we can think of them as iterative processes. Initial designs can be tested and refined with each launch and mission, learning from each experience to improve upon the last. This dynamic approach not only accelerates our progress but also fosters a culture of innovation and adaptability, essential traits for thriving in the cosmos. Beyond construction, technology also has the potential to enhance the quality of life within these habitats. Advanced life support systems, powered by artificial intelligence, can monitor atmospheric conditions, manage waste, and recycle resources with an efficiency that mirrors natural ecosystems. Imagine a habitat where air quality is continuously optimized, and water is purified and reused, creating a closed-loop system that minimizes waste and maximizes sustainability. Such technology could ensure that habitats are not just places of survival but thriving environments for human growth, creativity, and community. Moreover, communication technology will play a critical role in connecting these off-world habitats to Earth and to each other. High-speed data transmission will enable real-time updates, sharing of resources, and collaborative research across vast distances. This connectivity can keep us engaged with our home planet, ensuring that the cultural and scientific knowledge of humanity is shared, preserved, and expanded as we reach for the stars. As we venture further into space, we must also consider how technology can help us adapt to the psychological challenges of living in isolated and confined environments. Virtual reality, for instance, could be employed to create immersive experiences that provide mental stimulation and emotional support. Imagine astronauts engaging in virtual excursions that allow them to explore Earth-like environments while they are millions of miles away from home. Such innovations can help alleviate feelings of isolation, fostering a sense of community and connection even amidst the vastness of space. Energy solutions are another area where technology will shine brightly in the creation of sustainable habitats. Solar power, harnessed through advanced photovoltaic cells, will be crucial in providing a reliable energy source on planets like Mars, where sunlight is abundant, albeit less intense than on Earth. Innovations in energy storage will ensure that habitats can maintain power even during long Martian nights. Combined with nuclear power options for more consistent energy, these technologies will support everything from life support systems to recreational activities, making life in these habitats vibrant and sustainable. As we embark on this remarkable journey, we must remember that technology should serve humanity's deepest values. It is not merely about creating livable spaces but about fostering cultures and communities that reflect the best of what we can achieve. As we design habitats on other worlds, we hold the responsibility of ensuring these technologies enhance the human experience rather than diminish it. The promise of creating homes in the cosmos is not just about survival, it is about flourishing and discovering new ways to live meaningfully, together. In exploring the role of technology in habitat creation, we find ourselves at the intersection of human ingenuity and the vast potential of the universe. As we look to the stars, it is clear that the tools we develop today will shape the foundations of tomorrow's interstellar communities. The challenges ahead are immense, but so too are the possibilities, as we strive to transform distant worlds into vibrant homes for future generations. In the quest to create sustainable habitats beyond Earth, the question of energy becomes paramount. Energy is the lifeblood of any functioning ecosystem, and in the harsh realities of space, the stakes are even higher. As we embark on this cosmic journey, we must explore innovative solutions tailored for extraterrestrial environments, where traditional energy sources may not be viable. The sun, with its relentless power, emerges as a beacon of hope. Solar panels, already a staple of Earth's renewable energy landscape, could become the cornerstone of energy production on other celestial bodies, harnessing sunlight that bathes planets and moons. But beyond mere solar panels, the approach to energy in space must be multifaceted. For example, Mars, with its dusty red surface, receives only a fraction of the solar energy we experience on Earth. Yet, its long days could make solar energy a viable option if we can overcome the challenges of dust accumulation and radiation. Meanwhile, on the Moon, where the sun shines for 2 weeks at a time followed by 2 weeks of darkness, the design of energy systems must account for these extreme cycles. Here, innovative concepts like energy storage through advanced battery technologies or even lunar bases equipped with nuclear power sources could ensure a steady supply of energy, regardless of the lunar day-night cycle. Nuclear fission, with its potential for high energy output, presents another avenue worth exploring. Small modular reactors could be deployed to provide consistent and reliable energy for habitats, laboratories, and manufacturing facilities. Beyond fission, the dream of nuclear fusion, an energy source that mirrors the processes of the sun, offers tantalizing possibilities. If humanity can unlock the secrets of fusion, we could tap into an almost limitless supply of clean energy, fueling our ambitions across the solar system and beyond. As we venture into the dark stretches of space, we must also consider energy generation through more exotic concepts. Space-based solar power, for instance, envisions satellites equipped with solar panels that capture sunlight and convert it into microwaves, beaming energy back to Earth or to other locations in space. This technology could provide a continuous source of energy, bypassing the limitations faced on planetary surfaces. Such concepts might seem like science fiction today, but they are under serious exploration, reflecting our relentless pursuit of innovation. Energy is not just about powering machines, it's essential for sustaining life. Water, the essence of existence, will require energy for extraction and purification. Systems designed to harvest water from ice deposits, such as those found on Mars or beneath the lunar surface, will need energy to melt and process these resources. Desalination technologies, which have evolved considerably on Earth, could be adapted for use in extraterrestrial environments, ensuring a steady supply of clean water crucial for both human consumption and agricultural development. Food production, another vital aspect of life in space habitats, will depend heavily on energy. Hydroponic and aeroponic systems, which utilize nutrient-rich water or air to grow plants, require energy for lighting and nutrient delivery. By integrating renewable energy sources like solar and wind into these systems, we can create a self-sustaining cycle that supports not only human life but also the ecosystems we hope to cultivate. Imagine a thriving garden on the surface of Mars, sustained by a network of solar panels and energy-efficient systems working together in harmony. Yet, energy is not merely about survival, it also shapes our experience of living in space. The psychological well-being of inhabitants will be influenced by the energy solutions we choose. Artificial environments must replicate the comfort of Earth, and this includes adequate lighting, temperature control, and recreational spaces. Energy-efficient systems that create a sense of normalcy, like simulating dawn and dusk, will be crucial in maintaining a healthy psychological state for those living far from home. As we design these habitats, we must also consider the potential for energy sharing among communities. Imagine clusters of habitats, each equipped with their own energy generation systems, but connected in a way that allows them to share excess power. This interconnectedness would not only enhance resilience against energy shortages but also foster a sense of community and collaboration among inhabitants. However, the pursuit of energy solutions in space raises ethical questions as well. The extraction and use of extraterrestrial resources must be conducted with care, ensuring that we do not disrupt the delicate balance of these environments. As we harness the energy of the cosmos, we must remain guardians of the worlds we wish to inhabit, mindful of the impacts our technologies may have on their ecosystems. Looking further into the future, the possibilities for energy solutions expand even more dramatically. Concepts like asteroid mining could provide not only raw materials for construction but also abundant energy sources, tapping into the vast reservoirs of metals and other resources scattered throughout our solar system. Harnessing the kinetic energy of asteroids as they pass close to Earth or other planets may offer new forms of generation. Energy solutions for space habitats intertwine with our very survival and evolution as a species. The innovations we develop today will not just power our machines but will shape the landscapes of tomorrow's worlds. They will define our way of life, our relationships with one another, and our connection to the universe. As we push the boundaries of what is possible, the energy we harness will not only fuel our scientific endeavors but will ignite the flame of exploration, guiding us further into the depths of space and closer to realizing our cosmic calling. Water, often hailed as the essence of life, emerges as a central pillar in our quest to establish sustainable habitats beyond Earth. Its quest is a tale woven into the very fabric of cosmic exploration, where the search for this precious resource shapes our understanding of potential homes among the stars. The journey begins with a profound realization: water is not merely a resource, it is the foundation upon which life thrives. From the smallest microorganisms to the most complex ecosystems, water serves as a vital ingredient, necessary for biochemical processes, nutrient transport, and temperature regulation. As we gaze beyond our blue planet, the importance of water becomes strikingly clear. In the vast expanse of space, where conditions can be hostile and unforgiving, finding sources of water transforms from a mere necessity to a beacon of hope. When we look at celestial bodies like Mars, the icy moons of Jupiter, or the distant worlds of exoplanets, the presence of water signals the potential for life, past or present. Indeed, water is often considered the gold standard in our search for extraterrestrial environments capable of supporting life. Mars, with its ancient riverbeds and polar ice caps, tantalizes scientists with evidence that liquid water once flowed across its surface. This knowledge not only stokes our curiosity but also propels missions aimed at uncovering the Martian past. If we can confirm subsurface reservoirs, we may not just discover a history laden with water, but also the means to support future human colonization. On the Moon, water ice deposits at the poles represent another frontier. These icy treasures could provide essential resources for living, from drinking water to hydrogen and oxygen for fuel. Yet the quest for water in space extends beyond mere survival. It encompasses the sustainability of entire ecosystems. Closed-loop systems, where water is recycled and reused, are fundamental to life on Earth. As we venture into the cosmos, creating similar systems will be essential for maintaining human life and supporting plant growth in extraterrestrial habitats. Without a reliable supply of water, the dream of vibrant, self-sustaining communities becomes a distant fantasy. The technological advancements in extracting and purifying water from various sources will be pivotal as we forge our path into the universe. Innovations like the extraction of water from regolith, or the soil found on celestial bodies, demonstrate the potential of harnessing local resources. This not only alleviates the burden of transporting massive quantities of water from Earth but also paves the way for true extraterrestrial independence. Imagine habitats where water is treated like the gold it once was on Earth, a symbol of survival, innovation, and hope. The importance of water also highlights the delicate balance of ecosystems in space. Introducing water into an artificial environment will require meticulous planning and management. The interplay between water, air, and soil must be understood to create a thriving habitat. Astrobiology plays a crucial role in this endeavor, as scientists study viable ecosystems and their water requirements. By understanding how life adapts to extreme conditions on Earth, like in the freezing waters of Antarctica or the scorching springs of Yellowstone, we can design habitats that mimic these ecosystems, creating viable conditions for growth and sustainability beyond our planet. But our relationship with water extends beyond the physical. It influences our psychological well-being, shaping our experiences and perceptions of space environments. In the constrained quarters of a spacecraft or a habitat on Mars, access to water will offer not only sustenance but also comfort. The act of drinking, washing, or even gardening can provide a sense of normalcy amidst the chaos of space travel. Creating environments that include the calming presence of water can alleviate stress and foster community, reminding us of our connection to Earth and each other. Food production is intricately linked to our quest for water in space. Hydroponics and aquaponics present remarkable solutions for cultivating crops without soil, relying on nutrient-rich water to nourish plants. These systems, which can be cycled and adjusted to maximize efficiency, represent a significant leap toward sustainable food sources in extraterrestrial habitats. The ability to grow food in closed environments not only decreases dependence on resupply missions but also enhances the psychological aspects of space living, providing a connection to nature, even amidst the stars. As we contemplate the future, the ethical implications of water use in space must also be considered. As we embark on the colonization of other worlds, we must tread carefully, ensuring that our actions do not replicate the mistakes of Earth's past. The potential for contamination, resource depletion, and ecological disruption is a sobering reminder of our responsibility as cosmic architects. The stewardship of water will demand a conscious effort to balance the needs of exploration with the respect for new ecosystems we may encounter. Ultimately, the quest for water in space embodies humanity's deep connection to life itself. It represents our longing to understand our place in the universe and our determination to create a future where we can thrive among the stars. As we continue to unravel the mysteries of celestial water, we move closer to our vision of sustainable habitats. The discoveries we make today will not only inform our interstellar pursuits but also inspire generations to come, reminding us that every drop of water carries with it the promise of life, hope, and endless possibility. The journey is just beginning, and with each step, we are drawn deeper into the boundless wonders of the cosmos. As we journey deeper into the cosmos, it becomes increasingly vital to consider not only the physical structures of our future habitats but also the psychological landscape of those who will inhabit them. Long-term space habitation presents unique challenges to the human mind, and understanding these challenges is essential for designing environments that nurture mental well-being. Imagine the isolation of a distant planet, the expanse of a barren lunar surface, or the enclosed confines of a spacecraft hurtling through the void. These scenarios, while thrilling in their potential for discovery, also raise profound questions about the human experience in such extraordinary settings. The effects of prolonged confinement and isolation can weigh heavily on the psyche. Astronauts aboard the International Space Station have already reported feelings of loneliness and anxiety during extended missions. In environments where the sky is perpetually dark and the world outside feels both infinite and unreachable, fostering a sense of connection becomes paramount. This connection can manifest in many forms, whether it is through shared experiences with fellow colonists, a deep connection to the Earth from which they came, or even the echoes of familiar sounds and sights brought into the habitat. Designing habitats with an eye towards psychological well-being involves creating spaces that encourage social interaction and community. Open layouts that facilitate communication can help combat feelings of isolation, allowing inhabitants to share in their triumphs and struggles. Integrating communal areas for relaxation and recreation can also serve as vital outlets for stress relief. These shared spaces become sanctuaries of comfort and camaraderie, reminding everyone on board that they are not alone in this cosmic endeavor. Equally important is the balance between personal space and communal living. In a confined environment, the need for solitude becomes just as essential as the need for companionship. Designing private quarters that allow for moments of retreat can help individuals recharge and reflect. The challenge lies in ensuring these individual spaces do not feel like isolating cells, but rather personal sanctuaries that promote mental clarity and personal growth. Moreover, the impact of the surrounding environment cannot be underestimated. Access to natural light, even artificial forms of it, can drastically alter mood and mental health. Studies on Earth have shown that exposure to sunlight boosts serotonin levels, often referred to as the happy hormone. In space habitats, incorporating elements that mimic Earth's cycles, such as light and dark periods, can help regulate sleep patterns and enhance overall well-being. The psychological demands of space habitation also extend beyond the individual, touching on broader themes of purpose and identity. As humans venture further into the cosmos, they will inevitably grapple with existential questions about their role in this vast universe. Cultivating a sense of purpose can provide a vital anchor in the often disorienting expanse of space. Engaging inhabitants in meaningful work, whether it's scientific research, habitat maintenance, or artistic expression, can foster a sense of contribution that encourages mental resilience. Additionally, the inclusion of familiar earthly elements can create comfort in unsettling circumstances. Imagine greenery inside a spacecraft or habitat, a small indoor garden where inhabitants can cultivate plants, not just for sustenance, but as a living reminder of home. The act of nurturing life can anchor individuals, providing psychological solace amidst the alien surroundings. The vastness of space presents another layer of challenge, an endless horizon that can evoke feelings of insignificance or anxiety about the unknown. To counteract these feelings, it may be beneficial to create art and community events that celebrate achievements, big and small. Hosting gatherings to reflect on milestones fosters a sense of progress and belonging. Additionally, infusing habitats with cultural elements from Earth through music, art, and shared traditions can create a rich tapestry of human experience that transcends the barriers of space. Technology will play a critical role in enhancing mental health in space. Virtual reality could serve as a bridge to the familiar, allowing inhabitants to experience landscapes, sounds, and sensations from Earth. These technological innovations may help mitigate feelings of homesickness and isolation, creating a digital space for connection, creativity, and exploration without the limits of physical location. Mental health support systems must also be established, ensuring that psychological care is readily accessible. Just as we prioritize physical health in our journey beyond Earth, we must equally emphasize mental health. Training crew members in basic psychological first aid could empower them to support one another, fostering resilience within the community. Ultimately, as we design these future habitats, we must remember that the human spirit is remarkably adaptable. The challenges of space living can also give rise to extraordinary innovation and creativity. By anticipating the psychological effects of long-term space habitation and thoughtfully integrating design principles that nurture mental health, we can create environments where humans not only survive but truly thrive amidst the stars. As we contemplate the possibilities of life beyond Earth, the best designs will be those that harmonize with the intricacies of the human experience. Every brick we lay, every system we build, should echo the profound truth that to explore the cosmos is to embrace our humanity in all its complexity. In this grand endeavor, we are not merely cosmic architects but also caretakers of the human psyche, crafting spaces that invite wonder, connection, and the promise of a brighter tomorrow among the stars. As we turn our gaze toward the stars, the question of sustenance becomes vital. How will we provide food for ourselves as we venture into the cosmos? The challenge of growing food in extraterrestrial environments may seem daunting, yet it's a problem that has ignited the imaginations of scientists and innovators alike. Imagine a world where crops flourish in the sterile soil of Mars or the low gravity of the Moon. These innovations in agricultural techniques could redefine our relationship with food, not just as a source of nourishment, but as a cornerstone of our off-world existence. One of the most promising methods for growing food in space is hydroponics. This technique involves cultivating plants in nutrient-rich water instead of soil. Hydroponics allows for highly efficient use of resources, requiring far less water than traditional farming. In the confines of a spacecraft or a lunar habitat, where every drop of water and every ounce of soil is precious, hydroponics emerges as a practical solution. With the right setup, crops can be grown in vertical layers, maximizing space and light. This system not only conserves water but also minimizes the risks associated with soil-borne diseases, allowing us to nurture healthy plants in a controlled environment. In addition to hydroponics, aeroponics presents another avenue for growth. This method involves suspending plants in air and misting their roots with nutrient solutions. By eliminating the need for soil, aeroponics can further reduce the weight and volume of agricultural systems. This innovative approach not only accelerates plant growth but also allows for precise control over nutrients and environmental conditions, making it an ideal candidate for extraterrestrial agriculture. The implications of such systems extend beyond mere survival. They could enable us to cultivate a diverse range of crops, providing not just sustenance but also familiar flavors and the comfort of home. As we explore these advanced agricultural techniques, it's essential to consider the unique challenges posed by extraterrestrial environments. For instance, the intense radiation on the surface of Mars and the regolith, or lunar soil, lacking essential nutrients, require us to think creatively. Research into growing crops within protective greenhouses or using advanced materials to shield plants from radiation is underway. These habitats could mimic Earth's conditions, providing a safe haven for our crops to thrive while also serving as a psychological refuge for us. The sight of green, growing life amidst the barren landscapes of another planet could offer solace and hope, fostering a connection to our earthly origins. Bioregenerative life support systems represent another frontier in the quest for sustainable food production in space. These systems are designed to create a closed-loop environment where waste is recycled, and resources are continuously regenerated. By integrating the growth of food with waste processing, we can create self-sustaining ecosystems. Imagine a habitat where human waste is transformed into nutrients for crops, while the plants, in turn, produce oxygen and clean air for us to breathe. This interconnectedness could not only support human life but also foster a sense of stewardship and responsibility for the ecosystems we create beyond Earth. As we harness technology to address the challenges of food production in space, we must also pay attention to the psychological aspects of this endeavor. Food is deeply intertwined with our culture and identity, and in the harsh realities of space, it could become a source of comfort and community. The act of growing and sharing food could help forge connections among the inhabitants of extraterrestrial habitats, creating a sense of belonging in a place that feels alien. Each meal could be a celebration of life, a reminder of Earth's abundance, and a testament to human ingenuity. In tandem with these innovative agricultural techniques, the role of biotechnology cannot be overlooked. Genetic engineering offers a promising avenue for developing crops that can withstand the challenges of space environments. By altering the genetic makeup of plants, we can enhance their resilience to radiation, extreme temperatures, and nutrient-poor soils. These bioengineered crops could not only thrive on other planets but also yield higher nutrition, providing better sustenance for the inhabitants of space habitats. This intersection of biology and technology could enable us to explore new frontiers of human health and nutrition. Moreover, the concept of growing food on asteroids or other celestial bodies opens up a realm of possibilities. With resources abundant in these locations, we could establish agricultural outposts, tapping into local materials to support food production. Whether it's extracting water from icy comets or using the minerals from asteroids, the potential for growing food in these unlikely places adds another layer of excitement to our cosmic adventure. As we envision a future where humanity lives among the stars, the methods we employ for food production will be pivotal. They will not only sustain us physically but also nourish our spirits, connecting us to our shared human experience. Whether through hydroponics, aeroponics, or biotechnology, we are crafting a new narrative, one where we learn to cultivate life in environments that were once thought inhospitable. The journey to create sustainable food systems in space is as much about innovation as it is about understanding ourselves and our place in the universe. In nurturing life beyond Earth, we reinforce the notion that we are not merely explorers, we are cosmic caretakers. We are creating a legacy that will sustain future generations, not just in the quest for survival but in the pursuit of a rich, fulfilling existence amid the stars. With each new agricultural breakthrough, we are one step closer to realizing a vision of a thriving human presence in the cosmos, where the cultivation of food becomes a symbol of our resilience, creativity, and profound connection to life itself. As we look ahead to the possibility of human life beyond Earth, we must consider not only the physical needs of our species but also the emotional and psychological aspects that bind us together as a community. In the vast emptiness of space, where the flickering lights of stars feel both distant and intimate, the essence of our humanity might be more important than ever. The cultivation of community and cultural identity within space habitats will play a vital role in ensuring a thriving presence beyond our home planet. Imagine a settlement on Mars, or a lunar colony, where families reside in interconnected domes, sharing experiences and dreams while adapting to a wholly new environment. The geographical isolation and the psychological challenges of life on another celestial body could easily lead to feelings of loneliness and despair. Here, the fabric of community becomes our lifeline. Through shared experiences, collaborative efforts, and mutual support, we can foster a sense of belonging, even in the cold vacuum of space. Cultural identity provides a sense of continuity and connection to our origins. It's the stories we tell, the traditions we uphold, and the art we create that tether us to the past while propelling us into the future. In a place where the sky is not blue but a deep, unyielding black, the importance of carrying our cultures forward will be paramount. Picture astronauts sharing tales of earthly folklore during communal meals, or celebrating festivals that echo the seasons of their home planet. These rituals will serve as anchors, reminding inhabitants of their shared heritage and the diverse tapestry of human experience that spans continents and millennia. Moreover, culture is not static, it evolves and transforms. In the unique environments of space habitats, new artistic expressions could emerge, reflecting the trials and triumphs of living off-world. Imagine music inspired by the hum of life support systems, or visual art shaped by the surreal landscapes of alien terrains. As communities grow and adapt, so too will their cultural expressions, allowing for a rich synthesis of old and new. This evolving culture will not only help to forge bonds among individuals but will also act as a catalyst for creativity and innovation, a vital element for survival in the uncharted territories of space. The psychological aspects of living in close quarters with others can also not be overlooked. In confined spaces, relationships will be tested, and the need for empathy and understanding will be paramount. Communities must cultivate a culture of open communication and support, ensuring that every individual feels heard and valued. Programs that promote mental health, conflict resolution, and teamwork will be essential to maintain harmony within these new societal structures. In such extreme environments, how we approach education will also evolve. Learning will no longer be confined to classrooms but will take on a more experiential and collaborative shape. Children raised in space habitats might learn about their home planet through immersive virtual reality experiences, while also engaging in hands-on projects that connect them to their immediate surroundings in space. This blend of old-world knowledge and new-world experience will help forge a generation of thinkers and creators equipped to tackle the unique challenges of life beyond Earth. As we envision the future, one crucial element in fostering community and culture will be the establishment of governance models that reflect the diverse values of the inhabitants. These systems must encourage participation and inclusivity, drawing on the strengths of each individual to build a collective identity that honors the multitude of backgrounds from which we all come. The governance of space habitats must promote shared decision-making processes, ensuring that all voices are heard and respected, fostering unity in a shared mission. In the pursuit of a sustainable human presence in space, community may also provide the impetus for ethical discussions regarding our practices and relationships with other worlds. As we venture further into the cosmos, we will have to reckon with our responsibilities as stewards of new environments. The cultures we forge in space must reflect a commitment to sustainable practices and respect for the ecosystems we encounter. This ethical framework will not only guide our interactions with potential extraterrestrial life but will also shape the legacy we leave for future generations. Imagining a future where humanity thrives among the stars, we must remember that we are not embarking on this journey as isolated individuals but as a collective species. The strength of our communities, the richness of our cultures, and the shared stories of our struggles and successes will form the cornerstone of life beyond Earth. It is within these communities that we will find the resilience to face the challenges of an alien world, the creativity to adapt and innovate, and the solidarity to support one another as we explore the great unknown. The greatest adventure awaits us, but it will not be one of mere survival. It will be a journey filled with laughter and love, art and music, challenges and triumphs. In nurturing our communal bonds and celebrating our cultural identities, we will create a vibrant tapestry of life that echoes across the cosmos, a testament to the indomitable spirit of humanity. The stars are calling, and as we reach for them, let us do so hand in hand, hearts open, and dreams alive. As we stand on the brink of a new era, contemplating the vast expanse of the universe as our next backyard, it becomes imperative to engage with the profound ethical questions that arise from our pursuit of space colonization. These questions echo through the corridors of history and challenge us, not just as explorers, but as stewards of life itself. What responsibilities do we carry as we venture into the cosmos? Are we prepared to confront the moral implications of inhabiting worlds that may harbor their own forms of life, or are we merely repeating the mistakes of our past? The concept of colonization is steeped in complex historical narratives, often marked by exploitation and the disregard for indigenous cultures. As we gaze upward, imagining new homes on distant planets, we must acknowledge this legacy. The ethical implications of expanding humanity beyond Earth demand a thoughtful approach, one that respects the potential for existing ecosystems and life forms to flourish, regardless of their familiarity to us. We must ask ourselves, how can we ensure that our actions do not lead to the destruction of environments that could be as delicate as our own? In addition to the moral responsibility toward potential extraterrestrial life, there lies an obligation to preserve the integrity of the environments we seek to inhabit. When we consider Mars or the Moon, we are faced with the challenge of balancing our technological ambitions with environmental stewardship. The landscapes of these celestial bodies hold historical and scientific significance. They tell stories of formation and evolution, much like our own planet. How do we reconcile our desire to explore with a commitment to conservation? The answers lie in mindful planning, rooted in a sustainable ethos that prioritizes the long-term health of these worlds over short-term gains. The notion of space as a new frontier also raises questions about ownership and governance. As nations compete for the stars, how do we prevent the same patterns of imperialism and resource exploitation that have plagued earthly colonization? An ethical framework for space exploration must advocate for collaborative governance. This may involve international treaties that emphasize shared benefits and responsibilities, ensuring that no single entity can claim dominion over a celestial body. By promoting a cooperative approach, we can foster a sense of global unity, recognizing that the cosmos belongs to all humankind. Moreover, as we consider the societal implications of life beyond Earth, we must reflect on how we will build communities. The culture we create in space will shape not only our experiences but also the legacy we leave behind. Will we replicate terrestrial hierarchies, or can we forge new models of equity and inclusivity? This is an opportunity to envision societies that prioritize collaboration, innovation, and mutual respect. The ethical principles we establish now will resonate throughout generations, affecting how future inhabitants perceive their place in the universe. Another layer to our ethical considerations involves the psychological impact of space living. The isolation and confinement associated with long-duration space missions could affect our well-being, and as we design habitats, we must prioritize mental health alongside physical sustainability. Acknowledging the human need for connection, creativity, and community will be essential in shaping resilient habitats. Our approach to living in space should promote not just survival, but thriving, allowing individuals to flourish in an environment that nurtures their spirit. As we venture into the unknown, our pursuit of knowledge and discovery can also lead to unintentional consequences. The unintended impacts of our technology must be scrutinized. As we develop systems for waste management, energy collection, and life support, we must remain vigilant against potential harm to both our new environments and ourselves. The ethics of technological advancement demand that we question not only what we can do, but what we should do. The line between innovation and intrusion is often fine, and it is our responsibility to tread thoughtfully. Additionally, the question of who gets to participate in space colonization is pivotal. As we look toward creating habitats beyond Earth, we must ensure that space exploration is not just the privilege of a few, but an endeavor that includes diverse voices and perspectives. The irony of reaching for the stars while leaving behind marginalized communities on Earth is a contradiction we cannot afford to ignore. Ethical colonization means embracing diversity and ensuring that all of humanity has a stake in our celestial future. Finally, as we ponder the vast possibilities that lie ahead, the ethical considerations surrounding space colonization compel us to reflect on our identity as a species. We are the cosmic architects of our future, tasked with the dual responsibility of exploration and preservation. It is a delicate balance, one that requires humility and foresight. The universe may be expansive, yet our actions echo across the void, guiding the course of future civilizations. In navigating these profound ethical quandaries, we can cultivate a sense of cosmic stewardship, ensuring that as we reach for the stars, we do so with a consciousness of our place within the broader tapestry of the universe. As we design habitats for life beyond Earth, let us do so with compassion, respect, and an unwavering commitment to the principles that honor all forms of life. In this cosmic journey, we must remember that the true measure of our success will not only be the worlds we inhabit, but the legacy we create for those who come after us. As we gaze into the vast expanse of the cosmos, we can't help but wonder what lies beyond our solar system. The stars twinkle with possibilities, hinting at distant worlds waiting to be explored and perhaps inhabited. Interstellar travel beckons like a siren's call, inviting us to push the boundaries of our scientific understanding and technological prowess. But what would it take to reach these alien realms, and how might we create sustainable habitats there? Imagine for a moment a future where humanity has advanced beyond the confines of Earth and the familiar dance of our solar system, venturing into the abyss of interstellar space where stars like Proxima Centauri, just over 4 light-years away, become our new destinations. The idea of traveling to other star systems is both exhilarating and daunting. Current propulsion technologies need a monumental leap to achieve the required speeds to make such journeys feasible within a human lifetime. Concepts like the Alcubierre warp drive, which theorizes bending spacetime to allow faster-than-light travel, ignite our imaginations, even if they remain in the realm of theoretical physics for now. This journey through the cosmos would not just be about reaching new destinations, it would be about sustaining life in the most inhospitable environments imaginable. Habitats on distant planets would require revolutionary designs. These habitats would need to shield inhabitants from intense radiation, extreme temperatures, and the vacuum of space. To thrive beyond our solar system, we must envision living spaces that are self-sufficient, capable of recycling air and water, and generating food in closed-loop systems. Such designs would draw inspiration from the principles of biomimicry, where we look to nature for solutions in creating resilient ecosystems. On exoplanets, which we have only just begun to identify, the conditions may vary wildly. Some may have thick atmospheres with high pressure, while others might be scorched by relentless solar radiation. The challenge lies not only in traversing the great distances between stars but also in studying these worlds closely enough to determine their habitability. The field of astrobiology plays a critical role in this exploration, helping us understand what life might need to thrive elsewhere. Scientists are tirelessly working to uncover the secrets of these distant planets, examining atmospheric compositions and surface conditions through advanced telescopes and space missions. As we dream of building homes on distant worlds, we must also consider the technologies that could accompany us on this journey. Spacecraft capable of interstellar travel would need to be equipped with advanced life support systems, regenerative life cycles for essential resources, and innovative energy solutions. Harnessing the power of stars through solar sails could provide the thrust required for long voyages, while nuclear propulsion systems might offer another avenue for exploration. The feasibility of these technologies remains uncertain, yet the pursuit of knowledge continues to drive innovation forward. The psychological aspects of living in such environments cannot be overlooked either. Prolonged journeys through the void could lead to isolation and stress among crew members. Habitats would need to embrace not just the physical needs of their inhabitants, but their emotional and social needs as well. Creating environments that foster community and connection will be essential for maintaining mental well-being during these extended missions. This could involve designing communal spaces that mimic natural settings or developing virtual reality environments that provide an escape from the sterile confines of a spacecraft. Moreover, as we contemplate life beyond our solar system, we must also consider the ethical implications of space colonization. The potential to encounter extraterrestrial life raises profound questions about our responsibilities as interstellar travelers. What obligations do we have to preserve the ecosystems of other worlds? How can we ensure that our pursuit of new homes does not come at the cost of other forms of life? These are questions that require thoughtful reflection and guidance from diverse voices within our global community. In addition to the challenges we face in reaching and inhabiting new worlds, we must also envision the transformation of our culture in the process. Just as the exploration of the New World reshaped human society centuries ago, venturing into the stars will undoubtedly alter our perspectives and values. The experiences and knowledge we gain from these voyages could catalyze new forms of art, new philosophies, and perhaps even new forms of governance. The tapestry of human culture will only grow richer as we embrace our role as cosmic architects. So, what does the future hold for humanity among the stars? Each step we take today lays the groundwork for our tomorrow. Through collaboration and innovation, we are building the bridge from our home planet to the wider cosmos. As we harness the technological advancements of the present, from artificial intelligence to nanotechnology, we edge closer to making interstellar travel a reality. In this dream of cosmic exploration, we find not just the promise of new worlds, but the potential for a united human experience. A journey to distant stars may ultimately lead us back to ourselves, instilling a deep appreciation for our planet and a renewed sense of purpose. We are not merely voyagers through space, we are the custodians of life, bound by our collective responsibility to cherish and protect every world we touch. As we stand on the precipice of this remarkable journey, we must embrace the wonder of the cosmos and the possibilities it holds. Each star is a beacon of hope, reminding us that the universe is vast and filled with opportunity. The quest for sustainable habitats beyond our solar system is not just about survival, it is about thriving, about finding new ways to coexist in harmony with the universe and each other. With our eyes set on the stars, we forge ahead, ready to embrace our cosmic calling. As we journey deeper into this cosmic frontier, we encounter a remarkable cohort of visionaries, scientists, engineers, and dreamers whose ingenuity and passion are shaping the future of human habitation beyond Earth. These pioneers are not just responding to the challenges of space, they are actively redefining the possibilities of life among the stars. At the heart of their endeavors lies a commitment to understanding our universe and a desire to craft sustainable habitats that can support human life in the most inhospitable environments imaginable. Take, for instance, the work of astrobiologists who delve into the very essence of life itself. These scientists explore extreme environments on Earth, from the icy depths of Antarctica to the scorching heat of hydrothermal vents, collecting invaluable insights into how life can persevere under conditions once thought uninhabitable. Their findings illuminate the potential for life on other planets, suggesting that resilience and adaptation are not just earthly traits but universal constants. As they unravel the mysteries of extremophiles, organisms that thrive where others cannot, they inspire a new generation of thinkers who dream of discovering life beyond our planet. Then there are the engineers, the architects of our cosmic future. With minds akin to modern-day Da Vinci's, they design habitats that may one day grace the surfaces of Mars or the Moon. Their work involves intricate simulations and advanced materials that can withstand the harsh realities of space. Concepts like inflatable habitats and 3D printed structures made from extraterrestrial materials are not mere science fiction, they are rapidly becoming viable solutions. Inspired by the need for resilience, these engineers meld creativity with science, building prototypes that will test the limits of human ingenuity. Among these visionaries, we find the steadfast contributions of space agencies around the world. NASA has long been a beacon of exploration, but the vision extends beyond government organizations. Private companies, like SpaceX and Blue Origin, are driving innovation at unprecedented speeds. These companies challenge traditional paradigms of space travel, envisioning not just missions to Mars but entire cities on other worlds. Their ambitious goals have sparked a competitive spirit in the aerospace industry, spawning a new age of collaboration and ingenuity that reaches well beyond national borders. One cannot overlook the role of visionary thinkers, dreamers who awaken our collective imagination. Figures like Elon Musk and Jeff Bezos are not only fueling a new space race but are also inspiring a cultural movement that embraces the idea of becoming a multiplanetary species. Their ambitious plans ignite hope and curiosity, where visions of life on Mars or the Moon no longer seem distant dreams but realizable futures. They speak of interplanetary travel as a path to ensure humanity's survival, challenging us to think beyond the confines of Earth. This forward-thinking mentality reshapes how we view our relationship with the cosmos, emphasizing a proactive approach to exploring and settling new worlds. In recent years, we have also seen a rise in interdisciplinary collaboration, bridging the gap between the sciences and the arts. Artists and writers contribute to this dialogue about space habitation, envisioning not only what life might look like on distant planets but also how it will feel to live there. Their narratives explore the human experience in these new environments, contemplating the psychological impacts of isolation, the need for community, and the cultural expressions that evolve in response to life among the stars. This creative engagement offers essential insights into the emotional landscape of future settlers, reminding us that beyond the technical hurdles, the human spirit will play a pivotal role in our expansion into the cosmos. As we consider the potential for life beyond Earth, we encounter the ethical dimensions surrounding space exploration. Visionaries in this arena urge us to tread carefully, advocating for responsible colonization practices. They remind us that with great power comes great responsibility. We are called to honor the ecosystems we may encounter, ensuring that our presence does not lead to destruction but rather to coexistence. This ethical consideration is becoming a fundamental aspect of the conversation, reminding us that our quest for sustainable habitats must also encompass respect for the unknown. Looking ahead, these pioneers not only develop the technologies necessary for sustainable living off Earth, but they also advocate for a global approach to space exploration. Their vision embraces the idea that humanity, united, can face the challenges of establishing life beyond our planet. They envision a future where nations collaborate rather than compete, where pooling resources and knowledge allows dreams of interstellar habitation to flourish. In this collaborative spirit, we find a profound sense of hope and possibility. As we reflect on the contributions of these trailblazers, we begin to appreciate the magnitude of the task ahead. Designing habitats for life beyond Earth is not merely a technical challenge, it is a monumental journey that intertwines science, ethics, art, and humanity itself. Each visionary brings unique insights and perspectives that enrich this exploration, reminding us that our collective dreams shape the cosmos we seek to inhabit. In this unfolding narrative, we are reminded that the call to explore and inhabit new worlds is not solely about adventure. It is about ensuring a future for generations to come, a future where life can thrive in the vast tapestry of the universe. As we stand on the brink of this new era, we are compelled to support and empower these pioneers, fostering an environment where innovation can flourish and the wonders of the cosmos will be within our reach. Together, they are laying the groundwork for a brighter tomorrow, one where humanity's cosmic calling is not just a dream but a burgeoning reality. As we venture further into the cosmos, the road to sustainable living presents a vast terrain filled with challenges that demand our attention and ingenuity. Each step forward is met with uncertainties that not only test our technological limits but also our very understanding of life itself. For every promise of new worlds and habitats, there are hurdles that require collaborative thought, strategic planning, and a deep commitment to the principles of sustainability. One of the most pressing challenges is the sheer distance involved in our interstellar ambitions. Traveling to other planets, such as Mars or moons like Europa, will not only take significant time but also necessitate advanced propulsion technologies and life support systems that can function for extended periods in the harshness of space. The travel itself can take months or even years, and during that time, we must ensure that astronauts have access to food, water, and breathable air, all while mitigating the psychological challenges of isolation and confinement. This requires a level of engineering and foresight that we have yet to fully realize. In addition to the technical barriers, we must confront the environmental complexities of our chosen locations. Mars presents a host of obstacles, from its thin atmosphere to its frigid temperatures, while habitats on the Moon face radiation exposure and regolith that can be detrimental to equipment and health. Designing habitats that can not only protect future inhabitants but also utilize local resources will be crucial. This is where the principles of in situ resource utilization come into play, allowing us to harness the materials found on these celestial bodies to create sustainable environments. However, the technology to efficiently extract and utilize these resources remains in its infancy. Water, often hailed as the essence of life, poses another substantial challenge in our quest for space habitats. While some celestial bodies may have frozen water reserves, accessing and purifying this vital resource is no small feat. Developing systems to recycle water effectively and even create it from other elements is essential for long-term sustainability. This is an area ripe for innovation, as researchers work tirelessly to design systems that can operate autonomously in the unforgiving vacuum of space, transforming what we once considered mere science fiction into tangible solutions. Food production is yet another intricate puzzle we must solve. The conditions for growing crops on Earth are finely tuned, and replicating these conditions in extraterrestrial environments is fraught with complications. We must explore advanced agricultural techniques like hydroponics and aeroponics, which could allow us to cultivate food without soil, relying instead on nutrient-rich water solutions. The challenge extends beyond merely growing food. It involves ensuring nutritional diversity and food security for long-term missions, all while adapting to the limited space and resources available in a habitat. Moreover, as we design these habitats, we must consider the psychological well-being of the inhabitants. The isolation of space presents unique mental health challenges that could impact both individual and crew dynamics. Ensuring that future space dwellers have access to recreational activities, social interactions, and mental health support will be crucial for maintaining morale and productivity. The design of living spaces must foster community and connection, creating environments that feel human and welcoming, despite the alien surroundings. As we push the boundaries of our understanding and capabilities, the ethical implications of space colonization loom large. The potential for exploiting resources or disrupting extraterrestrial ecosystems raises essential questions about our role as cosmic stewards. We must tread carefully, ensuring that our pursuit of new frontiers does not come at the cost of ethical considerations for any potential life forms, no matter how small. The principles of stewardship and respect for these new worlds must guide our exploratory endeavors, anchoring our actions in a commitment to sustainability and responsibility. In parallel with these challenges, we cannot overlook the societal and cultural dimensions that accompany life beyond Earth. As we establish new habitats, we must think about the communities we wish to cultivate. How will we preserve our diverse cultures and traditions in these new environments? What will governance look like in extraterrestrial colonies, and how can we foster a sense of belonging and purpose? These questions are vital as we shape our identity among the stars and define what it means to be human in a new cosmic context. To overcome the myriad challenges ahead, collaboration across nations, disciplines, and sectors will be paramount. The development of sustainable habitats will require a convergence of expertise from fields such as engineering, biology, psychology, and ethics. Shared knowledge will empower innovative solutions that can address the multifaceted challenges we face. The more we work together, the better equipped we will be to confront uncertainties and seize the opportunities that lie in uncharted territories. Navigating the road to sustainable living in space will undoubtedly be complex and fraught with difficulties. Yet, with each challenge we encounter, we also find opportunities for growth, innovation, and discovery. By embracing a mindset rooted in curiosity and resilience, we can forge a path toward thriving habitats beyond our home planet. This journey will not only expand our horizons but will also deepen our connection to each other and the universe at large, reminding us that we are part of something far greater than ourselves. As we continue this exploration, we move closer to realizing the dream of sustainable living beyond Earth, a vision that beckons us forward into the boundless expanse of the cosmos. Imagine a future where humanity spreads across the stars, not as conquerors but as stewards of new worlds. This is a vision where we harmonize with the environment rather than exploit it. Picture communities on Mars, carefully constructed from the rich red soil, where every aspect of life is designed with sustainability in mind. Homes built from local materials, gardens flourishing under domes that mimic Earth's ecosystems, and energy sourced from the sun, harnessed through advanced solar technologies, creating a self-sustaining cycle of life. As we stand on the threshold of this new era, we must embrace the lessons learned from our experiences on Earth. The mistakes of the past guide us, they remind us of the importance of balance and respect for the natural world. We envision habitats where water is recycled through advanced systems, where crops are grown with precision using hydroponics and aeroponics, and where waste is treated not as a problem but as a resource. Through innovative techniques, we can create closed-loop systems that mimic the delicate balance of ecosystems, supporting life in a way that honors the planets we inhabit. In this future, the act of living off Earth transforms into an opportunity for profound growth. We will find ways to cultivate not only our physical surroundings but also our connections with one another. Communities will thrive through shared experiences, mutual support, and a collective spirit of exploration. Imagine children learning from the stars, gazing up at the untainted sky of a new planet, inspired to dream bigger and to explore more. These young pioneers will grow up knowing that they are part of an interplanetary tapestry, woven together with threads of diversity, knowledge, and shared purpose. Art and culture will flourish against the backdrop of this cosmic canvas. Imagine the rich tapestry of human expression ranging from music to visual arts, reflecting the pride and challenges of living on distant worlds. Each settlement will be a melting pot of ideas, traditions, and innovations. Festivals celebrating the first harvests or commemorating the arrival of new settlers will create a sense of belonging that transcends the vastness of space. The stories we tell, the art we create, and the connections we forge will bind us together, crafting a shared narrative that echoes through the stars. Yet, as we push the boundaries of our reach, we must also confront the ethical implications of our expansion. This new frontier demands a commitment to protecting any forms of life we may discover, as well as an unwavering dedication to preserving the environments we create. The ethical framework we develop will guide our actions, ensuring that our endeavors are grounded in respect and responsibility. We must cultivate a mindset that values coexistence, seeking to enrich rather than diminish the beauty of the worlds we touch. As technology marches forward, it will serve as a powerful ally in this journey. Artificial intelligence and robotics will play crucial roles in habitat construction and maintenance, allowing us to create environments that are not only livable but flourishing. Smart technologies will monitor ecosystems, ensuring that balance is maintained, and offering insights into how best to adapt to our surroundings. The marriage of humanity's ingenuity with nature will lead to habitats that are not just surviving but thriving, where biodiversity can flourish and ecosystems can regenerate. Energy solutions will evolve alongside these technologies, leading us to a future powered by inexhaustible sources. With advancements in fusion energy and harnessing the power of local celestial bodies, we can ensure that each colony is not only self-sufficient but also a beacon of innovation. Imagine a world where the energy of the sun fuels our every need, where the winds of alien landscapes generate power, and where the ability to harness geothermal energy transforms barren lands into vibrant havens of life. Water, the essence of life, will be secured through advanced extraction techniques, potentially from the icy moons of distant planets or through atmospheric collection systems on Mars. No longer will we view water as a scarce commodity, instead, it will be a vital resource managed with the utmost care and ingenuity. Our understanding of hydrology will evolve, allowing us to create water-rich environments that support lush landscapes and thriving communities. In our quest to establish a presence among the stars, we will also need to address the psychological aspects of space living. The challenges of isolation and the vastness of space can weigh heavily on the human spirit. Designing habitats that promote mental well-being, with spaces for reflection, community gatherings, and natural elements, will be paramount. The creation of virtual reality spaces, art hubs, and shared areas for social interaction will help maintain a sense of connection and purpose. As we ponder this vision for humanity's future in space, we cannot ignore the challenges ahead. Yet within each challenge lies the seed of opportunity. Our determination to face these hurdles will shape not only our survival but our evolution as a species. The cosmos is an uncharted realm, filled with possibility, and as we step forward, we do so with the knowledge that our journey is not just about exploration, it is about building a legacy. A legacy rooted in respect for both the worlds we leave behind and the ones we discover, reminding us that our cosmic calling is to thrive in harmony with the universe, transforming it as we transform ourselves. As we reflect on our shared journey toward becoming cosmic architects, we find ourselves at a pivotal moment in human history. The vastness of space beckons us, a realm of infinite possibilities, yet it also demands a profound sense of responsibility. Our exploration of the cosmos is not merely an adventure, it is a deep-seated mission to extend the very fabric of life beyond our fragile blue planet. We stand on the precipice of a new era, one that challenges us to not only reach for the stars but to do so with intention and care. The cosmos is filled with countless wonders, each celestial body swirling in a dance of cosmic creation. Yet with this wonder comes a stark realization: we are not alone in this universe. We share it with countless other forms of existence yet to be discovered, all potentially flourishing amidst the stars. As we seek to create sustainable habitats for life beyond Earth, we must remember that these environments are not just for us, they are a testament to our understanding of life itself. They represent our commitment to nurturing all forms of existence, ensuring that wherever we go, we carry with us the seeds of companionship and respect for the myriad forms life can take. Designing habitats on other worlds is an intricate tapestry woven from our knowledge of science, technology, and ethics. Every blueprint, every engineered environment, is a reflection of our values. As we contemplate our role as cosmic architects, we must ask ourselves, what kind of legacy do we wish to leave? In our pursuit of new homes on Mars, the Moon, or beyond, we have the opportunity to learn from the mistakes of history on Earth. This is a chance to build communities that prioritize sustainability, inclusivity, and harmony with the natural world. We have the power to create not just spaces where humanity can thrive, but ecosystems that respect and enhance the environments we inhabit. The principles of sustainable design serve as guiding stars in our quest. They remind us that our habitats must harmonize with their surroundings, utilizing resources wisely and ensuring that we do not deplete what we need to survive. Innovations in energy generation, waste recycling, and food production are not just technological advancements, they are ethical imperatives. As we construct our habitats, we must strive to create closed-loop systems that minimize impact and maximize the potential for life to flourish, echoing the intricate balance found in nature itself. Yet, our cosmic calling extends beyond the physical structures we build. It encompasses the mental and emotional landscapes of those who will inhabit these new worlds. The psychological aspects of living in space cannot be overlooked. As we forge paths into the unknown, we must consider the well-being of our communities. The isolation of deep space, the challenges of adaptation, and the need for human connection are all critical factors that will shape our experience. Fostering a sense of community and belonging in these new habitats will be essential as we aim to nurture not just survival, but a thriving existence. Moreover, the ethics of space colonization loom large in our minds. As we look to other planets and moons, we must grapple with profound questions about our place in the universe. What rights do we hold over other worlds? How do we balance our ambitions with the preservation of alien ecosystems? These questions are not merely philosophical, they will guide the decisions we make as we expand our presence among the stars. The lessons learned from Earth must inform our approach to new landscapes, ensuring we act as stewards rather than conquerors. As we envision the future, we cannot overlook the breathtaking possibilities that lie beyond our solar system. The stars that twinkle in our night sky teem with potential, igniting our imagination about interstellar travel and the prospect of encountering other civilizations. Each leap into the cosmos offers a chance to redefine what it means to be human and to expand our understanding of community across the galaxy. We are just beginning to scratch the surface of what is possible, and the thought of humanity venturing into the depths of space fills us with wonder. Yet, the road ahead is not without challenges. The journey to sustainable living beyond Earth will require unwavering commitment, collaboration, and innovation. It will demand that we unite as a species, pooling our resources, knowledge, and creativity to overcome the hurdles that lie in our path. We must embrace a spirit of exploration that encompasses not only the quest for new worlds but also the dedication to ensure those worlds are vibrant and sustainable. In the grand tapestry of existence, our cosmic calling is a thread woven with purpose and potential. As we embark on this journey to become cosmic architects, we are reminded that we are part of something much greater than ourselves. We are custodians of life, tasked with the responsibility to protect, nurture, and innovate as we expand our horizons. With every step we take, we honor not only our dreams but also the interconnectedness of all life in the universe. Together, let us answer our cosmic calling with courage and creativity, working to ensure that the legacy we leave is one of hope, harmony, and sustainability. The universe awaits, and so does the promise of a future filled with endless possibilities. As we reach for the stars, let us do so with the knowledge that in every corner of the cosmos, our journey is just beginning.